Okay, so today we are going to go through lesson 6.5.1. This is maximization problems. Okay, so we are going to look how to maximize area given a perimeter of fence. Okay, we're going to work on maximizing profits, whether we're selling candy at Cornfest or whether we are trying to maximize the profits from a crop yield. Okay, so some little bit of insight of what we're going to be working on today. So our first problem today, we're not going to solve this with our quadratic skills yet. We're going to just kind of do it by reason, and then next problem, we're going to actually use our knowledge from quadratics to help us solve these types of maximization problems. Okay, so this is our situation. So at Cornfest, Joe is selling bags of candy. Currently, he sells 300 bags at $5.50 per bag. So this unit is in dollar. Okay, so we can calculate that. So 300 bags. If he sells 300 bags at $5.50 per bag, his profit will be $1,650.
Jesus.
Yeah, that's.
Well, he also sold 300 of them.
Yeah, that is a lot.
He didn't profit that much money. He also has to buy it.
True.
Oh yeah.
That's a really good point. Well said. Okay, but we're not going to worry about that in this problem.
Should
Okay.
rob the candy.
Should what? Sorry.
He robbed the store.
I hope not. I went to
stealing bubble gum from the store.
I went to your Vauxhall confectionery for the first time yesterday. Is it? I think so.
Natural
Yeah.
grains?
Yeah.
Like, are the people that are selling it like,
Filipino?
yeah.
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 They have actually a really good selection of candy there. They sell like those big bins of sour soothers.
Yeah,
It's
they
my favorite candy, and I saw that. I'm like, should I buy it? I'm like, no. But now I'm still thinking about it. I might buy it on a Friday and see if I can eat it by the time Monday comes around.
I'd be able to eat it like in. I'm not gonna say that.
One time, I was playing like poker with my buddies after work. I used to work at Costco in Calgary, and we were just like hanging out. We would play poker after we would get off work. We worked the night shifts, and somebody bought a big tub of sour soothers, right? So we're just playing poker, eating the sour soothers, and then after like 3 hours of like eating them, my mouth was like raw,
bleeding.
It actually hurt for like 3 days.
There's so much to chew to.
They are, right? Okay, anyways, sorry about the distraction, but I just like talking about candy. And your natty greens, is that what you guys call it?
Yeah.
Natty G!
Yeah, natty G's is what it's called. Don't get her over
Shut
shell.
up.
Okay, so
I know.
this is his current price right here, so 300 bags at $5.50 a bag. But he wants to make more money, right? Because he's a baller, he's an entrepreneur, okay? So he's actually going to decrease the price by 25 cents a bag because he thinks if he does that, if he does reduce the price, he will sell more, okay? So if he does that, he thinks he will sell 25 more bags each day, okay? So in this case, the number of bags is going up and the cost of the bags is going down, okay? So each time, so we're gonna do a few calculations here. By increasing the number of bags by 25 and decreasing the cost by 25 cents, okay? So if we're increasing the bags by 25, we're gonna have 325 here. We're decreasing the cost by a quarter, so it's gonna be $5.25 here. And if he sells more bags at a lesser price, he's going to profit $1,706, okay? So, increasing the number of sales, but by decreasing the price, he can make more money, right? Because what we're going to find here, or maybe we will find here, is there going to be a maximum value in this situation, okay? Kind of like what we did with our vertex, right? A maximum vertex, okay? So we're just going to continue here. So we're going to go up by 25 for bags and down 25 cents for the price. Okay, the profit there is 1,750. Okay, we're just gonna continue. 375 bags at $4.75 will yield $1,781 in profit slash sales. Okay, 400, 450. We get $1,800. 425 at $4.25 will yield $1,806 in profits. And if we continue, 450 bags at $4 will yield $1,800.
So the most you can make is at 425.
Yeah, right? So the way that we can maximize our profits by increasing the number of bag sales is by decreasing the price. And we notice that we have maximum profit at the price of $4.25. Okay? So we could do this to solve problems going forward, right? It's kind of a lot of work though, right? Especially when we can use our knowledge of quadratics to help us solve this. Okay?
How would it help us solve this?
Because is what we are going to do, we're going to make an equation that we can put into a graph. So we're going to get it into standard form or factored form or vertex form. And then we're going to graph it. And then we're going to find the maximum based on the shape of the parabola.
Oh,
Okay? Good question. Okay? So we just found our value using a table of values. Okay? But how could we solve this without using a table of values? Okay? We're going to have a formula here. Okay? So in what we just did, we found that, so we had our y value is going to be the cost of the bag. So in this is what we did. The profit would be our y-axis. Okay? What we have just found, so the profit is the cost per bag multiplied by the number of bags. Okay? So we had just found the y component. So if we wanted to graph it, this would be our y-axis. Okay? And so is how we did that. So we did cost per bag. So this is like price, right? And then multiplied by the number. Okay, so the number of bags. And that's what we did. Okay? Now, we can use this so as our general formula for maximization problems to find, to be able to graph it and to find our vertex. Okay? So our unit here is y is equal to the base cost plus or minus the rate at which you're increasing your price or decreasing your price. Okay? Multiplied by the base number plus or minus if you're increasing or decreasing the base number. Okay? Note that one bracket will always be positive and one is going to be negative. Okay, so when you're setting up maximization problems, if you have a base cost and you're increasing the rate of your cost, you're going to be decreasing your number of sales, okay, and vice versa. So one bracket will always be plus and one bracket will always be minus, okay? So to go over what we did, so for us, we would have y is equal to, so our base cost was $5.50 minus what was the rate at which our base cost was changing?
25 cents.
Yeah, and was that going up or down?
Negative 25 cents.
Perfect. So decreasing by 25 cents. Okay, so that's just for one, right? But what if if I wanted to just say it generally, 0.25x, right? However many times you change that is just going to be x, right? Good. Now, what is so this was our price bracket, right? And next is our number bracket. So what was our base number? Looking at our chart.
300.
Okay, 300? 300? Nice. 300. And how was the rate of our base number changing?
Up 25.
Up 25, good. And how can I
Plus
write?
25x.
Great. Okay, plus 25x. Okay, so x would just be however many times you're changing it, right? That's kind of like the general pattern. Okay, so if you were to do that, you could graph it. Okay, I'm not too concerned about doing it. Okay, for this particular question. Okay, but this is just kind of what it would look like if we were to graph it. Okay. So if you were to expand this out, right, f your FOIL one, you would get y is equal to negative 6.25 x squared plus 62.5x plus 1650. Okay. I just skipped a few steps, but I just expanded what was in that bracket. Okay, so if I did 550 times 300 times 25x minus that, okay? So I don't want you guys to worry about that too much right now, okay? But now that it's in this form, what is the shape of my parabola going to be? Down, right? Yeah, it's a sad parabola, right? So on a graph, is this going to be a maximum or a minimum value? Maximum, good. And does that make sense? Yeah, it would. And in this case, what would be our maximum? What's our vertex going to be? What was our maximum value from our table of values?
1806.
Yeah, perfect. Okay, so so the x, yeah, so our maximum value there is going to be 1806. Okay, and don't worry about the x coordinate for that one because it's a little, yeah. So just our maximum value is going to be $1806. Okay, going forward, it'll the other problems will be better for x values. Okay. All good? So we can see our applications. Okay, this little formula here is going to be our friend. So we just got to make sure we can use that. Okay? Okay, cool. So we have a farmer who is growing beets in his field. He could harvest his crop now and get 3 tons per hectare, which would sell for $200 a ton. Each week that he waits, the yield will increase, right? The crop's going to keep on growing, but the price is going to drop by $10 per ton. Okay, so remember we have just our formula. So y is equal to the price plus or minus the change, right? Multiplied by the number. It's like moving the smartboard, the wind.
Yeah.
Cool. Okay, so what is our price and how much is it changing by?
The flags are gonna like rip off.
Yeah, the price is 200 and what is it changing by? Yeah, absolutely. It's changing by $10. And how can I make that a general statement? Like this is just for one particular case, right? But if I want to make it true for everything, it'll be 10x, right?
Oh,
And x will be how many weeks he waits, right? Okay, and then what is my number going to be? So remember, so this is gonna be the base number. So what is our base number?
3 tons.
3 tons, good. Oh, did you? Okay, sorry. I wasn't sure if you were choosing your 3 tons or your 0.3 tons. But what is the rate of change for this one?
0.3.
0.3. Up or minus? Up. Yeah, good. Plus 0.3. What am I not going to forget?
X.
X. Good.
I say it first.
Okay, so that looks good. And just for our units here, it's a real world problem. We just got to be careful with our units. A number without a unit is what?
1.
Just a number without a unit.
It's just a number, right? We don't know what the heck it is. Okay, it's just a number. So this is dollars per ton. And
He's making some shitty profit.
tons per hectare. Is that not a lot
No.
for beets?
No. Beets are heavy.
Yeah,
Or
$200.
beets aren't that heavy. I bet you that wouldn't be that much. I don't know what the average would be, but
I don't think
I would say probably 350 a ton.
Really?
350.
I don't make these problems, by the way. Okay.
Yeah, I know.
So, anyways, okay. And what is X?
how much tons you have.
No,
Would it not?
no.
No, X would be the increase for ton. X would be the increase for 0.3 tons.
Or decrease?
No. X is
Oh,
going
and
to
leave
be
money.
no,
The $10 hot pot, huh?
no. X is going to be the number of weeks that he.
John's, can I use the washer real quick?
Yep.
Yeah.
X is going to be the number of weeks that he waits.
You never know.
Okay. So yeah, so when we're setting up these problems, it's kind of important to understand like what is going on, right? So X is the number of weeks he waits. This is our price here in dollars per ton for our units, and this is our rate of change for the yield. Okay. So let's graph this. Okay, so I'm just gonna pull this up on Desmos and see what. Okay, so I got 200 minus 10x multiplied by 3 plus 0.3x. Gotta zoom way out on this one.
I tried using that Desmo.
Yeah,
It didn't work.
didn't work?
It gave me a line, like just a straight line.
I wish.
Put it in correctly.
Maybe you didn't.
I followed everything.
Okay, so important points of interest is the vertex
3 and 675. Or 673.
5.
5.
Yeah, 5 and
Oh, 5
675
and 675.
is what that looks like. Yeah. Okay, so I'm just gonna jump back over here and I'm just gonna sketch that over here. And just a sketch. Okay. And we said our vertex is 5 and 675. Okay? So what? What does that mean? What is our x?
Oh.
What is our-
X is 5.
Yeah, but what is our x? What does our x mean?
It means how many weeks.
Oh, how many weeks we wait?
Okay, thank you. So x is there. And then our y, what is our y?
The
The number times no.
wait.
Why?
So X.
The cost?
No, I think it'll
Close.
be the weight.
Nope.
Or the
You were-
tons per hectare.
You were really close, Maddie. Not the cost, but they're selling it, right? So the revenue.
Oh.
Okay? Yeah. So this is our revenue. Okay? Thank you for participating. I appreciate that. And this is our weeks. Okay? So, what is his maximum return?
$675 a ton.
Perfect.
That's more like it.
Oh, I didn't want to use blue. Hold on. 675 per ton. Good.
Just made $475.
And how many weeks should he wait to return or to harvest it? What did we find? What's our vertex?
It's at 5 weeks.
5 weeks, right?
Oh, yeah, okay.
5 weeks. And how many tons per hectare will he yield? Okay, so in this, so tons per hectare, okay, we are concerned with this one right here.
Just go 0.3 times by 5.
Exactly, okay?
Which is 3, 6, 9, 12, 15, 18, 2.1.
Okay, so we are going to do this by substitution, okay?
I know
So
it's 1.5.
we are only, for in this case, tons per hectare, we're only concerned with right here, okay? So y is equal to 3 plus 0.3 times x, okay? And what is our x value going to be?
5.
5.
3 plus 1.5, so y equals 4.5.
So we will substitute this in at x equals 5. So y is equal to 3 plus 0.3 times 5. 5 times 0.3 is 1.5. Is that what you said, Cody?
Yeah.
Nice. So 3 plus 1.5 is 4.5. So he will yield 4.5 tons per hectare.
I don't even know what a hectare is.
It's just a measurement.
Oh.
It's just, yeah. I actually don't know what a hectare is either.
Yeah, we definitely don't use it around here.
You guys, what is it?
Acre.
Acres, right. Do you know what 1 acre is?
In hectares?
No, just like 1 acre in general.
Now.
Apparently, I've heard this, is that 1 acre is the amount of land that one person can work in a day. Cause it's like an old ass measurement,
Like by hand?
but
Oh, sure, I hope not.
I don't know. I don't know. But that's just like the average area that one person can do. So if you have like a 4 acre land, it needs 4 people to work in one day.
I wouldn't want to work by hand an acre.
No, especially if you're like tilling or something like that, right? Okay, so our yield, is 4.5 tons per hectare, and how much will he earn per ton? So now we're concerned with this right here. Okay, so y is equal, and we're still going to substitute at x equals 5. Okay, so 200 minus 10 times 5. So 10
190
times
times 5 is 590, 680.
10 times 5 is 50.
680, 770, 860, 950.
Oh, you big brain.
150?
Where's Cody's?
Yeah.
Where did you go with this?
You're not supposed to go 200 minus 10 times 5.
Yep. 10 times 5 is 50,
Minus 15.
right?
Oh, I went 200. I went 190 times 5.
Yeah, that's okay. So $150
Did all that work for nothing.
per ton.
Yeah.
It's okay, you flexed your brain. I saw it.
And there's not much to flex here. Not that smart.
Hey, just gotta keep working at it.
Yeah.
Okay? How do you feel about this?
Good, actually.
Do we like
Yeah.
maximization? We like farming questions? Good. Okay, you guys good? If I change it, you need a second? Logan
Times it.
needs to catch up, but he's not here, so.
1039.
10:39, yep. So we still got like about an hour, okay? Got lots of time. And only one more example. So, neat.
We only have 2 questions.
Okay.
Oh, so are we doing this on our own?
The maximization worksheet?
Yeah.
Yeah.
Oh, the,
Yeah.
yeah, you're on those trees.
Okay, so example 2, a rancher has 500 meters of fencing and he wants to enclose a rectangular corral. Okay, so just a stock diagram of a corral. Okay, so this is gonna be my length, width.
Be 200 by 200 by 100 and 100. Oh wait, no, that's not 500.
We'll get there.
600.
We'll get there. Okay. So write an expression for the perimeter of the rectangle. So the perimeter is the outside border, right?
Isn't it, length times width?
You're thinking of area.
Oh.
Yeah, so just for perimeter. So how would I find the perimeter? How would I find the length of all 4 of these?
If it was a square,
Nope,
Times effect?
it's a rectangle.
Is it, no.
How would I find the perimeter of the outside?
Find the area inside?
Nope.
I don't know.
Nope.
I don't know.
Do you have to use length times width, times 2 or divide? Is that?
Nope, that's for a triangle.
You need numbers to do that too.
Okay, what if I wanted to just do it algebraically with variables, okay? So this is my side. So if you want to find the perimeter, right, it's the sum of all 4 of these sides, right?
Oh, plus.
Yeah, exactly, right? So if I wanted to find the perimeter of this, it would be length plus width plus length plus width, right? Could I simplify that at all?
Plus
Yeah, you
the-
go
times-
L squared plus W squared.
Careful, not squared.
Oh yeah, it'd be, you have to do
How many L's are here?
2, so 2L.
2L plus 2W, okay? Write an expression for the perimeter of the rectangle. Good. And we also know that the perimeter, he has 500 meters of fencing for that, right?
That's bigger than a football field.
So 500 meters is equal to 2 length plus 2 width. All good for there? Okay, Logan, if I wanted to find the area of the rectangle, how would I do that? Yep, length times width, very good. Length times width, very good. Okay, so this next one, this question here, C, there are a few steps to this one. So I'm just gonna write the 4 steps on the board here, okay? So maybe I'll write it over here. Okay, so, and I want you guys to write these down, please, because you're going to need to know how to do this. So step 1, you're going to use perimeter to solve for L.
Oh, I know how.
Okay,
Okay.
step 2, we're going to write the area equation with only one variable. Okay. 3, we're going to graph and find the vertex. And 4, we're going to find the length.
Amazing.
4 steps. It's a little shorter than AA's. What is it? 11, 10-step recovery program?
Oh, I thought you were talking about like alcoholics.
I was.
That's what he was
What
talking
do they have?
Oh.
13 steps? 12 steps?
I think it was like 10.
10 steps, right?
You
So,
would know, Cody.
so steps.
Alcoholics Anonymous.
That's scary. We should have probably all go to
No.
Don't ruin my fun.
Logan, if you need some support, I will go with you.
I will
I
not.
Oh,
think the
laughing.
next generation's gonna need it.
Imagine trying to solve
The
it.
next generation.
Like,
You know that kids
our
aren't-
kids
Our kids are drinking less and less than they did compared to like older generations.
Really?
Yeah.
Shocking. Apparently, if you
Are you
drink,
kidding?
apparently
I can
if you
bring that
drink more
average
than
up myself.
15 beer a week, you're considered to have an alcohol problem.
Yeah, that's a lot of beer.
A week
Did
for
you know
for a
those
male,
two
and it's only
babies, like,
8 for a
whiskey
woman.
on,
Yeah.
like a soother to
Me and
make
Dame were
them
talking about it last time.
There's the what?
David drinks.
like whiskey or like whatever alcohol.
They used to do like a cocaine tooth drops. I've seen advertisements for that, and it's yeah. So they'll like put the cocaine on their mouth because it's like a numbing agent. I'll actually show you guys the photo. It's from like the 40s though. Like dude, the 40s, 30s, 40s, 50s, Wild West.
Cocaine's
Yeah,
a
they
real
say it
problem.
was like a numbing thing, because anyone that's got like roofied with it or whatever.
It's a
or,
Wild West, right?
Like just numbs their whole face.
Okay, let's go back to math though, okay? So for step 1, where's my red marker? There it is. So step 1, use perimeter to find area. Or sorry, use perimeter to solve for L. Okay, so we have 500 is equal to 2L plus 2W. Okay, so we are going to arrange this formula here so L equals everything else. Okay,
Oh.
so we're going to get L all by itself. Okay, so how do we get L by itself? Well, we got to get rid of that 2W.
Divide 2 W's.
So let's subtract
Subtract
first.
2 W's.
Minus 2W from both sides. Okay. Now I have 500 minus 2W equals 2L.
Yeah, you want to get rid of those 2 L's.
Perfect. Or the 2, right?
Yeah.
So divide by 2. Divide by 2.
So 498 divided by 2, which is 246.
Okay. Hold on a sec, okay? So when you're doing the minus 2, okay, you can't just subtract it because we don't know the value of W,
Oh.
right? So we're still gonna have length is equal to 500 divided by 2, which is 250. Man, the smartboard's long today. So 500 divided by 2 is 250, and then 2 divided by 2 is 1, right? So minus W is equal to L, okay? So this is, we have now solved for L.
That's it.
This is L, yeah. So this is step 1.
That's both L's now?
Yep, yeah, because the lengths, they're the same size, right? It's a rectangle, so our L's will be the same size.
Like they're each 125 or they're each 250?
They're 250 minus W,
Oh.
okay? Because we're still in an equation right now, right? Okay, so step 2. Step 2 is write area equation with only one variable. Okay, so area is length times width. Okay, but we know that length is 250 minus W. Okay, so we're going to substitute that into L up here. Okay? So, area is equal to length times width. We know length is equal to 250 minus W multiplied by W.
Stupid kids.
Yeah, they're only 1 year younger
Who?
I think they're the grade 10s.
Those ones outside?
No, those are like grade 7.
Those are the grade
They're
7s.
so
I have not heard a
But-
single good thing about the grade 7 class.
But like,
Every grade.
literally like, there's people that have double classes, like they don't have to come out and scream.
Oh,
Okay,
you should have been here in grade 9. Every single teacher in the whole school hated our class.
Oh yeah.
Okay,
The
okay.
worst class.
now what? How do I make this a quadratic?
Solve for A. Or
No. So what are the degrees of my variables here? What is the level of the exponent on these?
it's just 1,
It's just 1, right? Quadratics have a degree of
2.
2. So how do I make this a quadratic?
Put them together.
Put them together, yeah, sure. Perfect. Okay, so I'll distribute the W in. Okay, so then, once I do that, I'll have A is equal to 250 W minus W squared. Good?
Oh, yeah.
Yeah? So this is a quadratic now, right? Do you agree?
Mhm.
Yeah, okay. Good. So, what's step 3?
Five.
Graph
Line.
and find the vertex.
Graph and find the vertex. Absolutely.
Yes, thank you very much.
Looks good.
Okay, so let's get our old friend out.
Everyone comment Logan's new haircut.
I
Old,
commented like the
Yeah,
first
she
day I
commented
saw it.
yes.
old
It
Desmos.
was the day before.
So we got negative x squared plus
I thought you were gonna be like me and get a buzz.
500x.
I did it before a basketball game, so I was a retard.
Yeah, you look like a
Hey, don't use that word.
Because I was idiot.
Can I go on my phone for like 2 seconds?
No.
Go.
It's a big one, up to.
You should be writing your quiz.
Almost 7,000.
Do you need help?
6,250.
There we go. So there is our vertex. Can you guys see that?
Yeah, it's 60. Oh, it's 62,000. I
Yeah.
thought it was 6,200.
250. Oh, that's a big one.
Language.
It's not even the first line.
Language.
Negative x squared. Oh, sorry. 250.
Logan, I'm gonna get my hair cut in for a moment. Just for you.
There it is. That looks
Get a
better.
bullet, Vernon.
Don't call me buddy. Just what you got.
Physics.
There we go, right here.
Just
Okay.
call me Brennan. Why
That's
do you
better.
call me by, like,
Okay, so there is our vertex. What does this tell us?
How tall it is.
Yeah.
How tall it is?
What does-
So here's our vertex. What is my x value and what is my y value?
125 and 15,620.
Yeah, okay, fine, sure. But what does that mean? What does that mean?
That are, I think it's, the range is y is greater than or equal to 15,625.
Okay, true.
Wait, what's
Why
our.
the length and next to width?
Say that again?
Is y the length next to width?
You're very close. Okay, so x is going to be our width. Okay, so when we had our problem, remember we had negative w squared plus 250w, right? So our variable is width, right? So like the x-axis is width. Okay, it's just like kind of the same thing. If we were using x as our variable, right? The x component is still like the variable, right? Does that make sense? Yeah? Okay. And then, so this is width, absolutely. And what is this one? Length? No.
What?
No. That would be way too long. 15,000 meters? Remember, we only have 500 meters of fence, right?
Yeah, no, that's feet.
What are we trying to maximize? Area, right? Area. Okay, so I'm just gonna jump back here. So our vertex was 125 and 15625. Okay, so this is our width, and this here is our area. Okay, so that was step 3, graphing and finding the vertex. And what is last but not least?
Find the length.
Perfect, find the length. Okay, so we're gonna find the length. So we know, so just from up here, so max area, 15625. What are the units on area? So we started out with meters, so I'll give you that one. Meters squared, yeah, good. Meters squared. And max width is what we found. $125 meters. Okay. So if we got to jump back to our top expression, so we had 500 is equal to 2 length plus 2 width. Right? What are we going to substitute in here? What did I just find? Did I pull you?
You just found the area?
We found the W, right?
Yeah.
The maximum width. So I'm going to substitute that in here. So at W is equal to 125. Okay, so then we get 500 is equal to 2L plus 2 times 125. I dinged that one up, sorry. So we gotta, I did it wrong, sorry. So length, we gotta go back to this one here. Length is equal to 250 minus our width, okay? Because we've already solved it in terms of L, right? And we know our W now, so we can just punch that in, okay? So sorry about that. So L is equal to 250 minus 125 minus our W. So if we have a width of 125 meters and we have a length of 125 meters, what shape do we have? A square. Good. And then if I put those lines up, that means that they are all equal. So this is the shape that would result in the maximum area. Doozy, eh? Okay, so I have a maximization worksheet for you guys to work on today.